Okay, let's find the equation of line segment CD with endpoint C, which is 3 and negative 4, and D, which is negative 1 and 6 in standard form. First off, we looked at the equation of a line in slope-intercept form, which looks like y is equal to mx plus b, right? And standard form is just another form of the line. It's just written as ax plus by plus c is equal to 0. Right, so technically it is your slope-intercept form, but you move all your terms to one side and you let the other side equal 0. Right? So what we could do is actually solve for our the equation of our line in slope-intercept form and then change it to y-intercept form. Into standard form. Alright, so let's look at the equation of our line in slope-intercept form. So we have 2 points, we have C and D, right? I'm just going to sketch this guy out just so you guys have an idea of what it looks like. Point C is found in, well, we know that this has a positive x-axis and a negative y value, right? So it should be found in the 4th quadrant, so it should be found somewhere here. So I'm just going to put that here. Okay, let's call this point C, and this is 3 and negative 4. And point D here is negative 1 and 6, right? So you can also notice here that this guy, negative x, positive y, I would probably find in the 2nd quadrant. I'm going to put it here, right? And this is point D. And once again, guys, this is like a scale, right? And what I want to do here is, this is my line segment, right? And these are the 2 endpoints of my line segment. And if I look at this, I want to figure out my slope, right? So I'm looking for my slope. Slope is y2 minus y1 over x2 minus x1. You can make point 1 any of these 2 points. It doesn't matter what the order is, right? So I'm going to call C here point 2. I'm going to call D here point 1. Right, so y2 here is negative 4, minus y1 here is 6, x2 here is 3, minus x1 here is negative 1. So make sure you guys pay attention to the integers, and you get negative 4 minus 6 and 3 plus 1, and you basically get negative 10 over 4. Okay, and this is approximately like negative 2.5, right? Or you guys can reduce this a little bit, right, and you can get this as negative 5 over 2 if you want. Okay, so the slope here is negative 5 over 2, and now we have y is equal to negative 5 over 2 x plus b. You want to solve for b, I'm going to substitute a point, so I'm going to substitute the point D, negative 1 and 6, right? Because we know that any point that lies on a line will satisfy the equation of the line. So I'm going to substitute this point into this equation. When I do that, I get 6 is equal to negative 5 over 2, negative 1 plus b, and 6 is equal to 5 over 2, the negatives will just kind of cancel out, plus b, and you have 6 over 1 is equal to 5 over 2 plus b. I'm going to just change this, make it a common denominator, so you get 12 over 2. I'm going to move the 5 over 2 to this side, isolate for b, so you get negative 5 over 2 is equal to b, and b here is equal to 7 over 2. So the equation here looks like y is equal to negative 5 over 2 x plus 7 over 2. Now this is the slope-intercept form. We're not done yet. We want to find this in standard form. If we want to find this in standard form, let's move all the terms to the left side. I'm going to make the right side 0. So y plus 5 over 2 x minus 7 over 2 is equal to 0. Now what standard form prefers is we want whole numbers, right? So we want whole number coefficients. So you can see that all of these guys have a denominator of 2. Right? This guy has a denominator of 1. If I can multiply everything by 2, I can just cancel out the denominators, right? Now, to do that, I'm going to multiply 2 to this side. Whatever I do to one side, if I repeat that to the other side, it just keeps it constant, right? So I'm just going to move this here. And when you're multiplying, you want to kind of distribute the 2 to all of these terms. So you get 2y plus 2 times 5 over 2, the 2's and the 2's will cancel out, right? So you get 5x, 2 times minus 7 over 2, the 2 and the 2 will cancel out. You get minus 7 is equal to 0. So this is what your equation looks like in standard form.